Hello, friends. Long time no see. We've got a very cool customer amplifier in today, and this is an old Magnatone from the 50s. Now, I happen to own this exact same amp, and it actually is the one that got me started on the vintage amp journey, the one that started me on working on amps. Is my first amp I ever touched with a soldering iron. So it is really cool, kind of full circle to have another one come in, and this one is in much more original shape than mine. Let's go ahead and flip it over, and I'm going to grab mine just to kind of show them side by side just for fun. All right, there you go. So this is mine on the right. This is the customer's on the left. And as you can see, they're Magnatone Varsity Deluxes. The model is model 108, if you can see that there. And yeah, really incredible amps. They got this crazy mother of toilet seat, as it's kind of known, covering here. It's just like a plastic covering. It's not really Tolex. And this really vibey kind of mint green chassis plate here. Just really, really cool amplifiers. So let's go ahead and put mine off to the side and inspect the customers here, open it up, see what we got, and let's get this thing running for them. And the reveal, of course, not inside the chassis yet, but reveal of the transformers, at least, the speaker, the tubes. First thing that catches your eye is the tube chart here. It's seen better days. Unfortunately, it is actually not even a tube chart. They just literally printed the entire schematic of the amp and glued it to the side, which I think is really cool. Mine is basically untouched. It's very, very clean on the schematic side. The rest of my amp is a basket case, but yeah, a bit unfortunate there, but we do have mine for the schematic if we need it. We got this speaker here. Looks like maybe an old Oxford or something. I don't know offhand, but that could be original. Got a 2-prong power cord. So that'll definitely be going. And then transformer-wise, let's see if I can view what they are. Looks like it says Thorderson, something along those lines. And I can't quite make out the lettering on this one from this angle. Let's go ahead and take a look at the tubes. For the rectifier, we've got an old Raytheon 5Y3. If you don't know, these are single-ended. These are kind of similar to Champs. Got an RCA 6V6. Very nice. It's a little bit dusty. This is a can cap right here. Looks to be the original can cap. And then for the one preamp tube, we have 12X7. Cool. So decent complement of tubes there. We can see the speaker is hardwired. A lot of extra wire here. So I'm not sure if this has been worked on before or not. I don't recall if the owner told me it did or didn't, but we will find out in about 1 second. So let's pull the chassis out. One thing to note for the owner when he watches this is these handles are kind of notorious for breaking. You can see it's kind of getting really weak right here on the edges. Mine had the original handle like this, and it did break on me as I was carrying it, just kind of eventually let go. So just a note there, if you're carrying, it's a light amp, so it's mostly okay, but probably best to just hold it from the sides because it is so small. So just a little note there. Let's take the chassis out. And here she is in all her simple glory. It's crazy how simple these things are. There's really not much going on, and it looks largely all original to me. Obviously, we had to disconnect the speaker from the output transformer wires. I am led to believe these are original because these look like they match the other green wires in here. And those look all untouched. It's kind of interesting. They give you a lot of excess wire there connected to the speaker. And yeah, let's just kind of take it all in for a second. So obviously we are missing a knob. I don't believe I mentioned that before. And this one does have the original pot here, which is a turn to turn it on, and then it functions as a pot. But that's kind of nice. Mine had a switch added at some point before I got it. We do see really just one modification area at first glance. That would be some electrical tape. Don't usually want to see that. Looks like this is for one of the two conductors of the 2-prong plug here. That's going right here. So some kind of splice happened there. No big deal. We'll replace all of this with a proper 3-prong. And yeah, so let's just go through it bit by bit since there's not a whole lot here. And first, let's just see what fuse is in it, just to see what we got. Looks like we got a 2 amp fuse. I believe this takes a 1.5 amp fuse, if I remember off the top of my head. In fact, we'll just leave that out because we want it out when we do the 3-prong. And let's just go piece by piece here. So we'll just start from the preamp section and move down. All right, I tilted it back a little bit so you guys can see it a bit better. Very interesting. So this is an example of a point-to-point hand-wired amp, which, you know, has some pluses and has some minuses, but this is pretty prototypical. Now, this has a lot of space, which makes it a bit less chaotic than like an old vintage Gibson or Silvertone or something. But with point-to-point, you get things like, you know, needing a large 1-watt resistor in a place that does not require a 1-watt resistor just to get the leads to reach. So this would be really, really tough to do if I had to change this resistor. You know, modern resistors, they don't sell them with leads that long, so you'd have to find a different solution. So just kind of interesting with point-to-point, kind of the stuff that the manufacturer had to do to make it work. We can see we got 3 inputs here. The first one is a shorting jack, which is very interesting to me. Mine's had some work done to it before I got it, and I did more work to it. So I never really got to see or explore one that was all original. So I'm very, very intrigued by what I'm seeing and really curious to hear how they sound compared to each other. So we'll definitely do that. At a later point, I think what we'll do, the game plan for this is, let's do the bare minimum, you know, as far as replacing the main electrolytics here. So this triple can cap, there are no modern replacements that will fit in that slot. So we will have to do discrete electrolytics inside the chassis, just like I had to do in mine. And we'll just leave this just unhooked. So that's just is what it is. So we'll do stuff like that, you know, perhaps replace this bypass cap. That's probably seen better days. But otherwise, keep it pretty original, assuming everything tests more or less okay. We'll have to check the bias as well. But it should be fine, I'm guessing. And we'll just kind of get a baseline, and then from there, hear how different they sound and whether, you know, the owner wants to do more mods or keep it as is. There's lots of potential. Mine has cathode bypass caps added, which will give more gain, more, you know, lows, more low mids. For example, right here, there could be a cap right here added. It's got a cap here for the other cathode, but it's a 0.1 microfarad. You know, typical Fender values at 25 microfarad, so much, much larger cap here. So the larger the cap, kind of the more gain is one way to look at it. And yes, there's definitely some opportunities to experiment a little bit with such a simple circuit, but we'll start simple. But everything looks pretty good. So I'm going to quickly grab the multimeter, check all of the resistors. These are all original, so I don't have to double check if they are the right value or not. We're just going to check if they're measuring what they should. So let's do that real quick. So first blush, everything looks to be pretty much spot on of what I would expect. Very little drift, actually. Really have no concerns with any of the resistors. The only real question mark one for us is just going to be the resistor for the cathode. So this resistor right here, this 330 ohm, I don't know if this is going to bias the tube correctly for us or not on modern wall voltages. That's really the only one we have any concern over. Everything else is going to be completely fine, at least at first glance. They might be noisy, you know, things like that, but we'll see. And then all the caps, these caps all should be fine. This one will likely replace, though we'll see. We might replace it more for tone reasons than for, you know, it failing. And yeah, nothing really else to say there. Very, very simple amplifier. So looking all the way down on this side here, really all we got to do is put in the 3-prong and test it. That's going to be kind of the first thing we got to do is just replace the 2-prong, make it safe, and then we can go ahead and plug it in and test it. This cap will be replaced for sure, but I'm sure it doesn't have problems that are, you know, so significant we can't turn it on to test it first. So let's go ahead and prepare for the 3-prong swap and go from there. One thing I don't think I mentioned already is this cap right here and what this does. So this is known as the death cap. You guys have probably heard that term before. If you're new to the amp world, this was basically a function of the olden ways where the amps were 2-prong. They would have this cap going to ground here. And it's known as the death cap because you can, if the cap fails, you can have high voltage going to the chassis itself. So you touch any metal or your guitar, you know, obviously you got your input jack going to your guitar and the metal and the strings, all of that, that can cause you get electrocuted. So this is something that we always remove when we work on amps. Some amps will keep it just for aesthetic reasons or just to because it's not in circuit and you can keep it in the amp without being in circuit. You know, vintage Fenders, for example, they usually go to a ground switch, polarity switch, which you can keep it hooked up to and just bypass the switch entirely. It's what I typically do. But in this case, there's no way for us to keep it in here and have it out of circuit. So we will be removing it from the fuse, removing it from ground here, and just providing it back to the owner when we're done. So just want to note that because I don't think I said anything about that before. Two prong removed. Now this is a massive hole to try and fill with a three prong. You know, typically you would use on a big Fender something like this. Now, I don't think it would it close? I guess it would. Okay, so that could work. I don't think I have one big enough. This one's obviously broken, but okay, that's good to know. I didn't think this would fit. Some good progress made on the three prong. So I did find a strain relief that fit just fine. One of the more modern, newer styles. First time I used one of those. So that's good to go. We got the hot going to the fuse tip, fuse sleeve going to the switch. Other end of the switch is the primary of the power transformer. The other primary is connected directly to the neutral here, heat shrunk. And then we've got the ground, which is the longest of the three wires. And we've already done a hash pattern in the chassis here to be able to solder directly to the chassis like that. So now we just got to take our big iron, get some solder on there. We've already cleaned it as well. It being the chassis. Now we'll just go ahead and heat up the blob and put the wire on top. And there you go. Three prong installed. So now we are safe to go ahead and turn it on, do some testing, check the bias, and go from there. So we're going to do that another day though, because tomorrow is Thanksgiving and I'm going to be out of town, but very, very cool amp. Glad we made some progress. So second for you guys and a few days for me. All right, cap replacement time. So we've got three caps here, really high quality FNTs, and then a high quality Vichet cap for the bias. So to show real quick, the bias cap, this teeny little blue guy, will go right here, right alongside in parallel with this resistor. This resistor is setting the bias, and we'll disconnect this brown lead, which is going to the filter cap here. And then the two FNTs will be replacing where this green wire is going and where this blue wire is going. So on either end of this resistor right here, this 22K, we will be putting a filter cap and a filter cap. And then we'll just kind of leave this as is like we talked about. The only other cap that probably might need to be replaced or we might look at would be this one right here. This is a cathode bypass cap for the preamp tube here. And 0.1, 400 volt. We'll see if this is leaking or not. Not sure, but we'll find out shortly. So first, let's take care of these three caps, and then we'll kind of sort out the rest here. So upon further review, there is a bit of a complication to this that I didn't really catch at first. And that's the fact that the screen node here, this filter cap, we've got the two plate resistors connected to it off of V1. So V1, pin 1, and pin 6. Those are your plate connections. And we got a 220K and a 47K connected to the 20 microfarad filter cap, which is also connected to pin 4, the screen connection, screen grid of the 6V6. So basically what we have to do is connect this end of the cap to here, here, and here simultaneously. How do you do that? That's not easy, right? So the nice thing about these can caps is obviously you can connect multiple things to them much more easily than just a, simple lead like that. So basically the only thing that we can do, because it's point-to-point wire, this is one of those quirks of it, if you will, is we have to add a terminal strip to be able to give us some additional connection points. So basically we have to get a terminal strip down and then we'll connect those resistors to it and then just reuse this green lead. So I'm kind of eyeing this spot right here. So this is the grounding tab for for the filter cap, the can cap here. If I can get that to kind of go here, then these resistor leads should be long enough to still reach that there. So it shouldn't really make much of a change. And yeah, I think that's really the only option, to be honest. And then we can put the capacitor somewhere over here because this brown lead will not be here anymore. So this will be open space. So that's kind of my leading plan, but just one of those quirks of an amp like this. It's not quite as easy as it might look at first. So first, let's just go ahead and remove all of the leads, try and be very clean about that, and go from there. So there's a few different options we have for attaching the tag strip. We could kind of try and open this up a little bit to be able to fit this. This is quite large though, so it would basically go from the end here to about here if we were to do it like this, kind of keeping it perpendicular. So that's one option. Another option would be to just solder it directly to the chassis, just kind of like that. I've done that before. I did that, I think, to mine. There's no real problem with that, but ideally you want some kind of mechanical connection as well. And I'm not going to drill into the chassis itself. I'm just not a big believer in that. Normally you can kind of steal, a bolt or something and go off of something existing, like, over on that side of the transformer bolts. But these are all rivets everywhere, so there's nothing for us to work with here. So the other option would be to use this as kind of a mechanical support, flatten it down, and kind of flatten it down on top of this. So you have some mechanical support, and then hit it with a soldering iron and get solder on top. So you kind of have double. And I think that's probably the best move here. So I think we're going to go ahead and move forward with that. We'll just kind of try and lay it down a bit more like this direction so that this can reach. I guess this is our limiting factor. So let's straighten out the leads on this resistor and just see what we got to work with. You might be saying, Tanner, why don't you just use new resistors so you don't have to try and unbend these resistors? Well, let me go ahead and grab a new resistor to show you the difference in length of what you get with new components. So this is a brand new off-the-shelf carbon comp. I'm not aware of any other type you can purchase. And let's look at the length here. So it's not even close to as long. It would not reach even, what it is now without any crimping on the ends here. So yeah, it's just, hopefully you can see that. So they just don't make them like they used to, unfortunately. So these measure fine. So there's nothing wrong with them. They're just a little bit bent. And the other nice thing with the vintage resistors is that they're very thick leads, so they can be bent more than modern ones. All right, that looks good. We had to be a little bit creative, but that's extremely solid. You can see we've got solder going from the chassis to the connection of the tag strip, as well as the mechanical connection of it being physically pressed down by that. So that's going to be rock solid, and we are definitely close enough to be able to connect these like so. So that's all good to go, and then we can go ahead and just connect the green there, and then we'll just get the cap kind of right over here-ish. Ground will go here, this will go there, and that's good to go. Okay, so we've got these three all soldered in. We're able to hook around the physical eyelet there. So there's a mechanical connection, just like I've been saying, both mechanical and solder. Now we just got to go ahead and attach the cap. I've already cleaned this area of the chassis, so we can go ahead and add some silicone to it. Get that in place. So we'll let that harden before we move the capacitor anymore. And we'll just be connecting the ground to one of these ground connections off the tube sockets. And then this end will obviously be going right here. And while that's happening, we can go ahead and shift our attention over to the bias supply here. So we'll go ahead and remove this brown wire and get this prepped for the cap. We've got the 22 microfarad cap replacing the can cap here. This is for the screen node. We've got the plate resistors here going to the screen grid on the 6v6. That's all good to go. And then we've got the bias cap here. Again, a little 22 microfarad 63 volt cap just in parallel with the resistor here. And the last one we have is just another 22 microfarad where this blue wire is going to. So we'll go ahead and remove this wire and get this dialed in a bit more. And then placement wise, I think we'll probably end up putting it maybe here, maybe something along these lines, but I'll have to play with it a little bit, see what we can do with these wires. So we'll be back in a bit. That worked out pretty well. We got the other filter cap all installed, again using the ground point on the tube sockets like you kind of got to in an amp like this. They are both siliconed down, rock solid. That's solid. So now we can go ahead and turn it on and test it. So we've got it plugged into the current limiter right now. The amplifier's on, no problems at all. So we're gonna go ahead and plug it directly into the Variac, and we'll go ahead and check the bias and make sure that this is okay. But we do have output, very quiet overall. Definitely not a gainy amp by any means. So I'm going to turn it off and let's check this bias. Checking the bias is super easy on an amp like this. Hand in the pocket, we're going to go ahead and just check the resistance of the cathode bias resistor. So it's 334 ohms. We're going to use the Rob Robinette tube bias calculator. I'm using the app right now, but you can find it on the desktop as well. So next, before we turn the amplifier on, we need the plate to cathode voltage. So just in prep for that, we're going to go ahead and hook the alligator clip to the resistor there. So we can measure here to get the voltage across the resistor, and then the voltage from there to the plate connection, which is pin 3. So let's go ahead and turn it on and get those voltages. Make sure we're in DC volts on the multimeter. Make sure you guys can see that, okay? So go ahead and turn it on. We do want the amp at its minimum volume setting there. So let it warm up for a sec. We should start seeing some voltage here. And there it is. It will show negative because I've obviously got the leads flipped, but it's no big deal. And you can see why having a, this is a 450 volt cap, I think, from the can cap, but this bias cap only needs to be, basically capable of 50 volts or around that range is totally fine. You can see we're only got 14 volts, 14.5 volts across it. So no big deal at all. No need for a giant cap for that. So it's going to take a little bit to warm up, but we can just do a quick reading right now. So 14.5, let's say, volts across the cathode resistor. 14.5. And then the plate to cathode voltage. So we want to carefully, again, hand in pocket, go to pin 3. And we're not connected to ground, we're connected to the cathode there. So 351. So let's check that. So we're biased at 120%, so actually quite hot, which is not surprising for a little amp like this. They tend to be biased very hot, especially on modern wall voltages. So to cool that down, we would need to change this resistor. It was a 334 ohm, probably go to a 470 maybe. I think that would be kind of the next in line. I'm trying to think if I have anything in between that. It's kind of an odd value, to be honest. There's not a ton of resistors you find in this value. So we could try a 470, but also running them this hot is not uncommon. I might try a different 6v6 just to confirm, with a known good that that's not a problem, but things are looking good so far. So we're gonna end here tonight and pick it up tomorrow. All right, it's a new day. We're back here at the amplifier. Upon further review, I think we're going to leave the resistor that's biasing the amplifier as is. 120% is actually not that much for a single-ended amp like this, just a single 6v6. I did some research. Seems like champs are biased much, much hotter than that, and that's part of their sound, I guess. So a little bit of inexperience as far as that's concerned, but I do know with cathode biased amps, you have to change the resistor value quite a bit to get any real movement because they're, kind of self-biasing. You can look at it. So to go from 120% down to 100%, which is not a huge jump, it would take quite a big leap in the resistor value, which would have effects on the plate voltage and change the tone in the end. So I think we're good to leave. It's got old 6v6 in it, not showing any signs of issues with me so far. So yeah, that's kind of where we're at. And then as far as testing the amplifier, I just have it alligator clipped here to the cab. I don't know if you can see it or not. Here, you can kind of see it right here. So we got the original cab. It's just connected to the speakers in the that came with the amplifier. So that'll just kind of be a quick little test, but we might install not install, but just kind of solder on a jack here to use to test with the aux box in the future. And I think, yeah, we'll kind of experiment a little bit, see maybe what it's like putting a cathode bypass cap on this cathode right here. Gives more gain, more grunt. See how that sounds. But for now, let's just go ahead and hear it as is and kind of just confirm we got some good sounds. So let's get that set up. So it's actually quite bright. I've got the tone all the way down right now, and I had it just there a little bit up. And yeah, definitely quite bright and quite clean. I'm playing a Strat, and yeah, just not a ton of gain going on. We'll turn it all the way up to hear how that sounds. But I'm not anticipating much. Yeah, super bright. Even with the tone rolled all the way down, like it is right now, turned all the way up. So yeah, it's a cool sound for sure. Let's just try to throw a cathode bypass cap on it real quick, just for fun. So we'll turn it off. Grab some alligator clips. Got the cap here. This will be a pretty sizable jump in volume and gain. This is just the same cap there, a little 22 microfarad. Let's hear how that sounds. Just hear without. Wow, listen to that volume change. Fascinating. Okay, well, amp works. We can call it good for right now. Do some more testing with the aux box, but pretty happy. And we're back here with the Magnatone. We've got the output wires connected to a jack here. That way we can plug a regular 1/4 inch into it. And that is running to the aux box just off camera there. And I just want to show you guys kind of a little bit of some testing I do that I haven't shown on my channel before, and just kind of give you guys a little bit of a peek into what that looks like. Now, I don't really have a good way to do this with the camera. You're viewing this from right now, so I'm going to use my phone for some of it, so bear with me. But yeah, pretty basic stuff. We've got the amplifier on right now. We've got it hooked up to a Variac. Let me grab my phone and show you guys the test. Switching to Handycam here. So I've got the amplifier on the Workbench, and I just want to kind of point out some things over here. First would be the Variac. So the amp is plugged into this, and this is plugged into the wall. I don't think I've shown my Variac on the channel before just because it's hard to fit in frame. But you can see we have it set to 120 volts, thereabouts. If I go directly into the wall and measure that, typically with all my lights on and everything, we're hovering around 117, 118, something like that. So this just gets us up to kind of normal range. And typically when I check bias on amplifiers, I go up to 121, just to give myself a little bit of a buffer. Here where I live, this is pretty average, 120. So we don't have really high peaks where I live. So yeah, that's what I like to do. And then we got the 1/4 inch out of the amplifier here, and that is running over to the aux box. Now this has been a great tool for me, and I don't know if I've shown this on the channel before. I think I've mentioned it in the past, and you guys have definitely heard it in the past. So this just allows me to record late at night, not wake up my daughter, and also do some testing as a low box. So basically I use it as a low box as well as a way to just kind of test with some headphones. So running into the aux box, 4 ohm load, that's what the original speaker is in the amplifier. And then on top of the aux box, we have a signal generator. So this just allows me to pump in a constant signal into the amplifier. In this case, we're at 100 times 10, so 1,000, so 1 kilohertz. Frequency, I typically do 1 kilohertz or 400 hertz to 500 hertz, somewhere in that range when I'm testing. And then we can see below that we have a scope. So this is an oscilloscope. This was basically getting ready to be thrown away at a like an e-waste kind of thing, and I was able to grab it. Still works. It's not perfect, but it does the job. And what we have is the oscilloscope hooked up to the output jack here. That way we can go ahead and measure the AC volts, or in other words, the signal, the audio signal, going through. And because we have a signal generator, we can send a very clean sine wave to the amplifier for testing purposes. So the amp is currently on right now. And I'm going to go ahead and just turn the volume knob up, and you will see on the oscilloscope a wave start to appear. Keep going. So there you go. So now we have the amp. This is basically the max clean headroom. If you look at the peaks and valleys, they're just starting to flatten out on the bottom just a hair. So this is basically your max clean wattage, if you will. And a way to measure that and to actually get a number is to go ahead and pull your multimeter and have that hooked up. So I have the multimeter connected right here. So we want to connect this to the positive side. Try and do this carefully. And then we want to measure AC volts on the multimeter. So obviously we're grounded. Checking AC volts. So 4.3 volts AC. And again, we're not clipping on the waveform. So we times that by itself or square it. So 4.3 times 4.3. And then we divide that by the impedance of the cab it's running into, in this case 4, or the load it's running into. So it's running into a 4 ohm load. And so that gives us about I think it was 4.7 watts or so. So that's kind of a rough estimate of what we're running with, which is what you'd expect for a champ style amp. You'd expect 5 watts, and we're just about there. So yeah, everything is looking good so far. The waveform looks really nice. Now, one interesting thing I want to show real quick, and I'll do that to make the waveform smaller, is how the tone control affects the waveform. So right now we have it pretty much all the way down. And if I turn, I'm going to turn the tone control up. And we're about halfway. And look at that. So really from the last quarter turn, you can see it starts to introduce asymmetrical clipping. You got clipping on the bottom there. So you see where it gets flat clipping, and you see this little kind of knee right here. So you got, I believe it's called crossover distortion. I think that's what it's called. And yeah, so just kind of interesting how the tone, because it's really reductive. When you roll it all the way up, you're getting the maximum. So if we wanted to check the wattage with the maximum output there, we'd have to roll back. You can see even still we've got kind of little quirks in the wave there with the tone all the way up. And so you can see, you know, something like that, we're getting a little bit more output. Now it's 4.4, 4.5 AC volts, so we're closer to 5 watts like that with a little bit of funkiness with the wave. So yeah, there you go. Just wanted to show a little handy cam. So when I do kind of long-term burn-in testing with the amplifiers, what I'll do is I'll run a signal through them, through the aux box, and I'll just kind of let that run and keep an eye on it, make sure everything's okay. We'll watch the bias, and you know, just it's a good stress test, and it's been really, really great for me. This has been my #1 tool, honestly, with tech work since I've gotten it. A lot of people just use some large resistors, which is exactly what's inside this, just large resistors, to do a load on the amplifier. And but this allows me to grab headphones and actually listen to the amp and play it turned up all the way, you know, without causing any problems. So yeah, there you go. This thing is looking great. From here, we're just going to do some stress tests on the amp, just let it run for a little bit, make sure it's good to go, but everything's seeming super solid. And then just talk to the owner and see what he wants to do as far as, you know, if we want to experiment modding it at all or just keep it as is. Maybe we'll throw in a couple tubes in it just to kind of see how these are doing. That's one thing I don't have as a tube tester, but a great tester of tubes is the amplifier itself. So I've got some known good ones we could swap in and just see if anything changes. And yeah, otherwise this amp is obviously very simple and pretty much good to go as far as I'm concerned. So right on. We'll pick this up when I hear back from the owner and go from there.